Today I will discuss about neighborhood of a point in real analysis. Let C be a point in R and we take a subset of R and let S contained in R. Then S is called a neighborhood of the point C if there exists an open interval AB such that C belongs to this open interval AB and this open interval AB contained in S. If this condition is satisfied, then S is called a neighborhood of C. Now, S is a set which contains an interval AB and this interval AB contains the point C. Therefore, C belongs to S obviously. Suppose S is a neighborhood of C. Then there exists an open interval AB by definition. Then there exists an open interval AB such that AB contained in S and C belongs to AB. Therefore, if this suppose this set S and S is a neighborhood of C, therefore C belongs to S and there exists an open interval AB such that this open interval belongs contained in S. Similarly, there is another open interval let D which is also contained in S and containing the point C. There is another open interval FG that also contained in S and containing the point C. So here C belongs to open interval AB that contained in S. C belongs to open interval D that also contained in S. C belongs to open interval FG that also contained in S. So there are many intervals that containing the point C and containing S. So here we can derive another definition of neighborhood. Let S be a subset of R. Then S is called a neighborhood of the point C if there exists an open interval C minus delta to C plus delta. This is plus such that C minus delta to C plus delta contained in S where delta greater than 0. If this condition is satisfied, then S is called a neighborhood of C. Now the set S, this belongs to C. So if there exists C minus delta to C plus delta such that this interval contained in S, then S is called a neighborhood of C. If we increase delta, then this will be also, suppose this is C plus delta 1, C minus delta 1, where delta 1 greater than 0. If we increase also, then this will be C minus delta 2, this will be C plus delta 2. So where delta 2 greater than delta 1, greater than 0. So if we increase delta, then we can find all intervals that contain in S and containing the point C. So this is the definition of neighborhood. And clearly, C belongs to open interval AB contained in S. We know a set S contained in itself. Therefore, an open interval AB contained in an open interval AB and C belongs to this open interval AB. So also open interval AB is a neighborhood of C. Now this open interval AB is a neighborhood of C and denoted by NC. By definition of neighborhood, C belongs to open interval AB containing S, and open interval AB containing open interval AB. C belongs to open interval AB, therefore open interval AB is a neighborhood of C and is denoted by NC. Similarly, this interval is also neighborhood of C and this interval is denoted by N delta C. N suffix delta C bracket. Delta neighborhood of C is called. Now consider S equals to closed interval 1 3 closed. Closed interval 1 3 equals to definition क्या है? X belongs to R real number such that 1 less than equals to X less than equals to 3. ये है definition. Now let 2 belongs to closed interval 1 3 and there exists an open interval 1 3 that contained in closed interval 1 3 and 2 belongs to this open interval, suppose this 1, this is 2, this is 3, open interval. So 2 belongs to open interval 1 3 and 1 3 contained in closed interval 1 3. Therefore 2 is a neighborhood. Therefore closed interval 1 3 is a neighborhood of 2. But there exists no open interval that containing the point 1 and contained in closed interval 1 3. 1 belongs to closed interval 1 3 but 1 does not belongs to open interval 1 3. 1 does not belongs to open interval 1 2. 1 does not belongs to open interval 1 3 by 2. 1 and also this interval contained in 1 3 but 1 does not belongs to this interval. Hence closed interval 1 3 is not a neighborhood of 1. So we here conclude that a closed bounded interval 1 3 is a closed bounded interval containing the point 1 but not a neighborhood of 1. So a closed and bounded interval, a closed and bounded interval containing the point C may not be the neighborhood of C. One 3 2 belongs to open interval 1 3 contained in closed interval 1 3. So this closed interval 1 3 is a neighborhood of 2 but 1 belongs to closed interval 1 3. Closed interval containing the point C. So closed interval 1 3 containing 1 but may not be the neighborhood of C. Here closed interval 1 3 is not the neighborhood of 1. 1 does not belongs to any open interval AB that contained in closed interval 1 3. So we can conclude this. In next video I will discuss about properties of neighborhood.